This is for topic 3, homework part 1, problem 1, specifically on part C. And when we did part A, we had 3 points, P, Q, and R, and we just drew the lines between them. And we saw that there were 3 lines. And part B, there were 4 points. And when we connected all of the points together, we got 6 lines. And so in part C, we want to use the observations, the things you might have noticed while you were drawing the lines, to create a conjecture that addresses the question, how many lines are determined by n points? So we're going to assume that only pairs of points are collinear, not 3 or more. So we're not going to have like dot, dot, dot. That changes the answer. So we want to focus on things like this, in particular, where here, like where we had 4 points and only 2 of them were collinear. We did not have 3 in a row. And so we just want to focus on that part. And so to come up with a conjecture, basically what we need to do is think about how we were connecting the dots. Do some sort of systematic walkthrough and trying to understand why the total is what it is because of the way that we connect the dots. And there are a variety of ways of thinking about this. What I put into the key, and which is what I'm going to do here in this video, it's not the only way to think of it. It is one way to think of it. And what we want to do is think of it in a way that we could then extend the idea to any number of points, not just 3, not just 4, not just 5, but any number of points, and use our conjecture, the formula that we come up with for it, to be a predictor. If we had the same setup and we knew the number of points ahead of time, we could then predict how many lines would be connecting. So the first thing I notice is when I'm connecting, like here's n equals 3 points. And I want to connect 1 point to all the others. So if I connect P to Q, I get 1 line like this, and I get 1 line like this. And that gives me 2 lines to connect with. And what I recognize is that when I have the 3 points, the one I want to connect to the others, and I specifically said that, the one that I want to connect to the others, not how many of the others, just thinking globally, generically. There are n points, and I have to use one of those points to connect to the others that are left. So that means that there are n-1 points to connect to. So for the first point, I'm going to create n-1 lines, n being the number of points. I subtract 1 because I'm starting with 1, and that leaves me n-1 points to connect to. That's 3 minus 1. That gave me the 2 lines. And we can do the same thing over here where n equals 4. If I say B is the first point I'm going to connect to the other points, then there are n-1, 4 minus 1 equals 3 other points to connect to. So I connect 1, 2, and 3. So that's where I've got my n-1 3 lines that I created by connecting 1 point to the n-1 other points that are left. And so I'm saying n-1. I don't want to think specifically the numbers. I want to think generically, because I'm trying to extend the pattern that I'm doing here to make that generic formula. So that was the first bullet point that I put in the key. And the second bullet point says the second point connects to all but the first, meaning that it's already connected to the first. So we're not going to draw a new line from the second back to the first. That's already been taken care of. So the second point has to connect to all of the other points. And that's what we're thinking when we say one point's already been used. That was our first point. Now, out of the remaining ones, we're going to use another point, and we connect it to all the others. So however many points there were, we have to subtract off 2 from that total, 1 from the one that was already used, and 1 that we're going to be using to connect to all the other points. And this created more lines. In this case, 3 minus 2 equals 1, one more line. Over here, I want to connect D to all the other points. It's already connected to B. B has already been connected, so it's really no longer in the game. And we say, all right, we have n minus 1 points. Well, I have 1 point already used. I'm pulling another point out of the set. And so D can only connect to n minus 2 other points, just like Q only connected to n minus 2 points. So D connected to C, and it connects to A. So first, B connected to the other points, then D connected to not B, and it's not connecting to itself, so it connects to the remaining points. Now here, n minus 3 is 3 minus 3, that's 0. There are no other points that can be connected. All the points are connected with all the other points. And so we got a total of 3 lines, which is what we expected, or what we saw in part A. But over here, we still have some points that aren't connected. And C is the third point that we want to connect to all the rest. And it connects to A, and there's nothing else that it can connect to that it hasn't already been connected to. So that's 4 minus 3 equals 1. We got one line. And so when we add them all up, we see 6. We got 1, 2, 3, 4, 5, and 6. 3 from the first point connecting to all the rest. 2 from the second point connecting to all the remaining ones, 1 from the third point connecting to all the remaining ones, and the fourth point, so n minus n equals 0, okay, or n minus 4 equals 4 minus 4 equals 0. That's the last point. It's already been connected to everyone else, so it contributes no more lines to it. Now that's what we want to think of generically. So let's do an imaginary 5 points here. Oops, that can't be there because it would be collinear with the others. Okay, so I have 5 points that are where only 2 of them are collinear at once. So let's see how it connects out. This is my first point, and I connect it to 1, 2, 3, 4 points. So n minus 1 is 5 minus 1 equals 4. I made 4 connections from the 1 point out of the 5. I could connect to 4 other points. So there's my n minus 1. Then my n minus 2 is, we've already used this point. Let's use this one and connect it to all the rest. There are n minus 2 points left to connect. So if I say n minus 2, that's 3. I expect to make 3 more lines, 1, 2, and 3. n minus 3 equals 5 minus 3 equals 2. The next point that I work with, I expect to make 2 lines, 1, 2. And then n minus 4 equals 5 minus 4 equals 1. I expect to make 1 more connection. That's it. And you can see that every single line has been every single point has been connected to all the other points. And so the total that we got is 4 plus 3 plus 2 plus 1, that's 10. So that's the idea of what I was trying to express in the key. And so now what we want to do is show how to bring all these ideas, the n minus 1, n minus 2, all the way to n minus 0, n minus, you keep going, because if you don't know what n is, then you just keep going until you get to n minus n0, and that tells you to stop. So we want to express that in terms of a formula. And so what I saw when I was doing this was I said, well, first I make n minus 1 lines, and then I make n minus 2 lines. So I want to add them together, and then I make n minus 3 lines, and I want to keep going in that pattern, subtracting a bigger and bigger number until I get to n minus n, which we all know is 0, but it kind of helps to just feel like we're counting down. You can stop at n minus 1, but this seems to be more comfortable in people's heads. So this is the formula that I wrote. This is the total number of lines. Now, we saw here, this is a perfectly fine answer right to there. Mathematically, we can compact this a little bit, and we can have some fun with it. Okay, so if we look at the pattern, we generated n minus 1, n minus 2, n minus 3, all the way to n minus n by and coming up with these numbers. But what we see then is we're actually adding 0 and 1 and 2 and 3 and 4 all the way up to n minus 1, because we always have to start with n minus 1, the number of points that we have minus the 1 point that we're going to connect all the others. So this same total is equal to 0 plus 1 plus 2 plus ... plus n minus 1. And we see that 0 plus 1 plus 2 plus 3 plus 4, 0 plus 1 plus 2 plus 3, 4, n equals 4. So that's another way we can look at it. And that's a way to simplify the formula. We have another way of simplifying the formula, and I'm not going to go over the proof of it. I will just give you the idea of what's going on. But let's look at 1 plus 2 plus 3 plus 4. That's for n equals 5. We know that 4 plus 1 is 5, and we know that 2 plus 3 is 5. So what we have is 5 plus 5 equals 10, which is what we got. We can also see this as 2 times n was equal to 10. That's just one way of looking at it. I don't think I want to take it much further than that. I think this is a clearer formula for us. All we have to do is just say, look, if you want to know the total number of lines, if you know the number of points n, then you just add up 1 plus 2 plus 3 plus 4 all the way up to n minus 1, and you will get that total. If you want to explore this a little bit more, ask me about Gauss, Gauss.